Your electrical panel may be quietly wasting hundreds of dollars a year right now. And almost nobody in America ever checks it because the heat never looks dangerous until the bill arrives. 30 days ago, I shoved a thin plastic grocery bag beside my breaker panel, the same cheap produce bag you grab at Walmart for onions and apples, and my electric bill dropped by $38. No gadget, no tool, no energy-saving device, just a crumpled plastic bag sitting inside the outer panel door doing absolutely nothing. At least that's what I thought. Honestly, I expected this to be fake internet garbage. The kind of thing people post next to miracle fuel savers and magnets for your water pipes. But then the panel temperature changed. Then the breaker door stopped feeling warm. And when I pulled up the utility usage graph late one night and compared the numbers side by side, that's when this stopped sounding ridiculous and started becoming very hard to explain. Before you think I'm about to sell you some revolutionary energy-saving breakthrough, relax. There's no affiliate link under this video. No sponsored gadget. No subscription box. No secret device I'm about to pull out of my garage like a late-night infomercial. I'm talking about a 10-cent grocery store produce bag. That's it. The same thin plastic bag sitting next to the lettuce and bananas at every Walmart and Kroger in America. And honestly, that's exactly why I ignored this idea the first time I heard it. It sounded too stupid to work. Which raises a much stranger question. If this actually works, why has nobody ever mentioned it? Most people think their electric bill comes from the obvious stuff. The air conditioner, the water heater, the dryer running too long. But buried behind that gray metal panel in your basement or garage is something almost nobody talks about. Electrical resistance quietly turning part of your power into wasted heat every single day. Put your hand against your breaker panel after the AC has been cycling for an hour and you'll feel it. Not enough to scare you. Just enough warmth to feel normal. That warmth is money. It's electricity you already paid for bleeding into the walls of your house instead of powering anything useful. And the system is built so you never question it because the loss happens silently, a few degrees at a time. Hidden behind steel and drywall while your meter keeps spinning outside. Utility companies don't need you to waste massive amounts of power all at once. They profit from millions of homes leaking tiny amounts constantly. And the strange part is, your panel may be doing this every second your house is awake. The easiest way to understand this is to stop thinking about electricity like magic and start thinking about it like water moving through pipes. When water hits a narrow section of pipe, pressure builds. Electricity behaves the same way. The harder current pushes through wires, breakers, and connections, the more resistance it encounters. And resistance always creates heat. That heat doesn't appear out of nowhere. It comes directly from energy you already paid for. You've felt this your entire life without realizing what you were touching. A phone charger warm in your hand after sitting in the outlet all night. An extension cord getting hot behind a space heater in winter. That heavy laptop brick sitting on the carpet like a tiny heating pad. Even the breaker panel itself slowly warming after the dryer. Oven and AC are all running at the same time. Your house is full of small, invisible heat leaks, hiding inside ordinary electrical load, and because each one seems harmless by itself, nobody ever questions the bigger pattern forming underneath it all. At least, that's what I thought, until the first experiment completely failed. The first time I tried this, absolutely nothing happened. Same electric bill, same warm breaker panel, same feeling that I had wasted an entire weekend chasing another piece of internet nonsense. I tested thick freezer bags, heavy trash bags, even one of those reusable grocery bags everybody keeps stuffed under the kitchen sink. Zero difference. Around midnight one night, I was sitting in my garage staring at utility data on my laptop, honestly feeling embarrassed that I had taken any of this seriously at all. That's the part most people online leave out: the failure. The doubt. The moment you almost quit because the idea sounds too ridiculous to survive contact with reality. Then one tiny detail changed the entire experiment. 3 nights later, I was sitting in a dark room with nothing but the glow of my monitor, and the utility company usage graph pulled up full screen. I wasn't even looking for savings anymore. I was trying to prove to myself the whole thing was fake so I could stop thinking about it. But when I compared the hourly usage data side by side, something immediately felt wrong. The heavy load evenings, the hours when the AC compressor, water heater, and basement dehumidifier normally pushed my usage through the roof, had dropped noticeably, not by a few random spikes. Consistently, I zoomed in thinking maybe I was comparing different weather conditions. I checked the outdoor temperature history. I checked occupancy. I checked appliance runtime. Then I repeated the measurements again the next night, and the pattern stayed there. That's the moment my stomach honestly tightened a little, because this stopped feeling like coincidence and started feeling measurable. The breaker panel door was cooler, the peak load hours were lower, and the graph was showing reductions I couldn't easily explain away anymore. I remember just sitting there staring at the screen thinking, okay, what exactly am I looking at here? That sent me digging through patent archives I probably never should have opened. At 2 o'clock in the morning, I ended up reading through industrial cooling patents written for electrical infrastructure. Most homeowners never even think about transformer stations, high-load switching systems, commercial power distribution equipment. That's where I found repeated references to resistive heat management and passive thermal reduction methods involving low-density polymer materials. One filing led me to ABB, the massive Swiss-Swedish engineering company that builds electrical systems at an industrial scale most people can barely imagine. Another reference pointed toward a small ETH Zurich study discussing measurable reductions in resistive loss inside enclosed, energized systems under controlled cooling conditions. None of this was written for homeowners. None of it mentioned breaker panels in suburban garages. But the underlying principle kept appearing over and over again in different forms. Small temperature reductions inside high-load electrical environments can create disproportionately large efficiency changes over time. And buried inside one of those filings was a detail almost nobody pays attention to. The second experiment started with a completely different bag, not a thick freezer bag, not a reusable shopping bag, the thinnest, cheapest produce bag I could find sitting on a metal rack under fluorescent lights at Walmart. The kind that sticks to your fingers when you try to open it. When I got home, I stood in my basement, holding that crinkling plastic in both hands, while the breaker panel hummed softly through the wall beside me. The metal door felt faintly warm under my fingertips from the air conditioner cycling upstairs. I remember taking a breath and thinking about how ridiculous the whole scene would look to anyone walking in right now. Then I crumpled the bag slowly instead of folding it flat. Loose. Wrinkled. Full of tiny trapped air pockets. The sound echoed sharply in the quiet basement like dry leaves being crushed together. That detail turned out to matter more than I expected. I opened only the outer panel door, never the inner cover, with the exposed wiring, and placed the bag carefully at the bottom of the enclosure below the breakers where the trapped heat naturally settled. Nothing plugged in. Nothing attached. No moving parts. Just a thin layer of wrinkled plastic sitting inside warm, stagnant air while the house carried on normally above me. Then I closed the panel door and left it there for 30 days. But before you try this yourself, there's one thing you absolutely need to check first. Let me be extremely clear about this. Do not open the inner panel cover. Behind that metal shield are live bus bars carrying enough current to kill you before you hit the floor. This experiment is only for healthy electrical panels with normal operating temperatures. If your breaker door feels genuinely hot, if you smell burning plastic, hear buzzing, or notice flickering lights, stop immediately and call an electrician, because that's not normal resistive heat anymore. That's a failing system. Because the first thing that changed wasn't the electric bill, it was the heat. A week into the second test, I borrowed a thermal camera from a friend who works commercial HVAC because I wanted to stop guessing and actually see what was happening inside that panel area. The first image I pulled up honestly made me sit there in silence for a second. Before the bag, the breaker panel surface showed broad orange and red heat patches spreading upward from the main breaker area every time the AC and dryer were running together. You could literally see the heat bleeding through the steel door into the surrounding wall. but with the thin crumpled bag sitting inside the lower enclosure, the thermal image looked noticeably different. The hottest zones had tightened and dimmed, not frozen, not magically cold, just lower, controlled, more contained. I ran the test 3 separate evenings because I didn't trust what I was seeing the first time. Same result every night. Then I tried the simplest test possible, the back of my hand against the panel door after the house had been under heavy electrical load for almost an hour. Before the experiment, the metal felt uncomfortably warm after a few seconds. Now my hand just stayed there. Cool steel. Normal room temperature. And that was the moment this whole thing crossed from interesting theory into holy SH times T territory for me, because you could physically feel the difference without needing a single graph or explanation. And then the monthly bill finally came in. When the new electric bill finally showed up in my inbox, I didn't open it right away. I remember staring at the notification for a solid minute because part of me still expected this entire thing to collapse. The second real numbers entered the conversation. Then I opened the usage report and immediately went to the peak load days. First, the brutal hot evenings when the AC compressor, dehumidifier, kitchen appliances, and water heater were all fighting at the same time. That's where the difference showed up hardest. The total usage had dropped, but the strange part was how consistent the reduction looked during startup heavy hours. The AC wasn't running dramatically less. The house temperature hadn't changed, but the electrical spikes during compressor startup were visibly smoother compared to the previous month. I actually removed the bag after the first billing cycle because I wanted to kill the placebo effect completely. 5 days later, the panel surface started warming again. 7 days later, the daily usage trend slowly climbed back up. Then I repeated the entire test one more time with a fresh, thin produce bag and watched the numbers drop again under nearly identical weather conditions. That's the moment I stopped asking whether something was happening and started asking what exactly I was affecting inside that panel. Because once you see a pattern repeat under controlled conditions, your brain stops treating it like coincidence. That should have been the end of the experiment. Instead, it opened a much stranger question. After that, I started noticing heat everywhere in my house. The refrigerator compressor humming warm against the kitchen floor, the laptop charger sitting behind my desk like a tiny space heater, even when nothing was plugged into it, the sump pump controller in the basement, giving off faint warmth 24 hours a day. Once you start paying attention, you realize modern homes are full of invisible electrical inefficiency, quietly bleeding energy into the air 1 degree at a time. Not enough to trigger alarms, not enough to look broken, just thousands of tiny thermal losses stacked on top of each other month after month while your utility meter keeps turning outside. That's what made this experiment stop feeling like a weird internet trick and start feeling more like a hidden layer of infrastructure most people never think about, because the waste is designed to feel normal. And that's when I started testing something even stranger. A few days later, I tried something I'm still not fully convinced is safe or even explainable yet. I placed another thin LDPE bag near the well pump pressure switch in my basement. Not inside the housing, just nearby. And the pump cycling frequency appeared to change slightly over the next week. My current theory involves possible RF interference reduction around the switch contacts, but honestly, I'm still testing that idea because the data isn't clean enough yet. Because once you start noticing invisible waste, it becomes hard to stop seeing it. So if you decide to try this in your own house, I genuinely want to know what happens. Not just whether your bill changes, but where you live, what kind of climate you're in, whether your biggest loads come from air conditioning, electric heat, well pumps, or old appliances. Houses in Arizona behave differently than houses in Maine. Older breaker panels behave differently than newer ones. The interesting part now isn't my result anymore, it's whether the same pattern appears across hundreds of completely different homes under completely different conditions. That's how hidden infrastructure stops being internet folklore and starts becoming measurable reality. And honestly, that may be the most important part of this entire story. The strange thing about modern life is that the biggest losses are usually the ones nobody teaches you to see. Not dramatic failures, not sparks or smoke or alarms going off in the middle of the night. Just small, invisible inefficiencies quietly running in the background for years while everybody accepts them as normal because they were designed to blend into the walls around you. A warm breaker panel, a humming transformer, a charger that never cools down, tiny leaks of energy hiding inside systems most people stopped questioning a long time ago. And maybe that's why this experiment bothered me so much after it worked. Because it forced me to wonder how many other things in the average American home are quietly draining power, money, and efficiency simply because nobody ever thought to look closely at them. Sometimes the most expensive part of modern infrastructure isn't what breaks, it's what keeps wasting energy unnoticed while you slowly get used to it.